Hey, what is up? We have been talking about all kinds of things in class. For instance, collecting data, analyzing data, trying to come up with some type of information from a data set. So what we're going to do next is we're going to start taking these skills and start applying them to what's called hypothesis testing, right? Which of course begs the following question. Yeah, so what actually is hypothesis testing? Okay, so let's first of all just define this word hypothesis real quick. Right? So for a hypothesis, right, all this really is a statement that's being made. Right? And what we're doing is we're making this statement regarding something about a population, right? So it's going to be regarding a characteristic of, let's say, one or more populations. Right? But it really is just a claim that's being made, right? So for example, right, we could say that 80% of Americans like cheese. Right? That is a statement regarding this characteristic of all Americans. Right? So in this case, the Americans are the population, and the statement is that 80% of the population likes cheese. Right? Here is another example that, and let me move this back down, another example of a hypothesis. Right? Let's say you go to the store, you buy some lights, and on the light package itself, you see this statement. Right? So a package of lights, right, or in this case, light bulbs, has a life of 300 hours each. Right? So in this case, our population would be all the light bulbs that this one particular distributor makes. Right? And the claim that we're making about this characteristic, about this population, is that it has a characteristic of lasting 300 hours each. Right? So where we're going to start going in this particular section is what's called hypothesis testing. Right? In other words, we're going to be testing these claims that various people or companies or media outlets are actually making. Okay? So what a hypothesis testing does is it's just a procedure that we're going to develop that's based on really sample evidence. Right? And also some probability thrown in there. Right? And what we're going to do is we're going to use the sample and use probability, and we're going to use it to test a hypothesis. Right? So that's again what it is. Right? So a hypothesis is just a statement that someone somewhere has made somewhere along the way. So what we're going to do is we're going to test it to see how true that hypothesis is. And the way we're going to test it is we're going to collect data, and then we're going to do all that stuff that we have been doing, maybe finding averages, sample proportions, using our normal distribution, all this stuff we've been working with. Right? We're going to use all these tools that we've got in our tool case now to test whether or not this statement actually makes sense or not. Right? So let's talk about the steps that we're going to try to follow in this particular process. Right? All right. First of all, let's make a statement about a population. Right? And that could be us or it could be somebody else, right? But let's just make a statement about a population. Right? And again, like we saw in the previous examples, populations could be people, light bulbs, dogs, cats, anything, right? Any group that you're trying to test, that's your population. Right? So once we've got that statement made, what we're going to do next is we are going to collect data. Right? And of course, the way we're going to collect our data is we'll just pull out some type of a sample from the population. Right? And what we're going to do is we're going to collect this data to use as evidence. Because someone's made a claim out there, so we need to find some type of way to test that claim, and we're going to collect some evidence to see if their statement, probability-wise, should happen or should not happen. Right? So then once we've collected our data, what we're going to do is analyze the data Right? And of course, again, when I say data, we're talking about the data that's coming from the sample. Right? And what we're going to do is we're going to analyze the data to see the possibility or the plausibility of the statement that was made, right? Or maybe the hypothesis, if you want to check that. All right, so here's how we're going to actually test this out, right? The first thing we're going to do is we're going to assume the claim is true. Right? So when we're collecting our data, we're not going to have any preconceptions at all. We're just going to say, okay, let's just check and see if your claim actually does work, right? So let's assume that it's true, and then we're going to collect our data, and then what we're going to do is we're going to look at that sample and ask ourselves this question, right? What is the probability that, whoops, I'm going to keep on moving this thing, sorry about that, that if the statement is true, what is the probability that if the statement is true, we would have generated this sample? Right? And we'll probably use our normal distribution to help us find these probabilities along the way. Right? So if you remember when we talked about before, how when we're starting to take our data, we wanted to try to figure out, all right, what level do we want to use to start to believe something is true or believe something is false? We said usually if it happens, 5% of the time, 1 out of 20 times, that's starting to be on the fringes of being unbelievable. But if it happens 1 in 10 times, 1 in 5 times, in other words, 10% of the time, 5% of the time, 20% of the time, those are okay. But once it starts getting less than 5%, then we start to kind of wonder about it, right? So if we look at our sample and we say that this happens 5% of the time, or 10% of the time, or 15% of the time, then we can't really reject what they're saying, right? So if the probability the sample occurs is high, and again, by high, what we're usually saying is that some probability, let's call it alpha, is bigger than or equal to 5%. And again, you can change this to 3%, 1%, but just generally 5% is kind of the go-to, right? So if the probability the sample occurs is high, then this is not evidence to reject the reject the claim. Right? And on the flip side, if we go through this and if we say if the probability the sample occurs is low, right? So in this case, we're saying it happens less than 5% of the time. Okay? Then this is evidence to reject the claim. So again, what we're saying is, if your statement's true, then I should not have been able to pull out this sample. So since I pulled out this sample, there's a problem with your statement, right? So that's where we're going to kind of go with this, right? And this thing, alpha, that we're using here, that's what we're going to start calling the level of significance. And we'll go into more detail on what that is here in just a little bit, okay? All right, so let's go into a little bit of terminology here that the book uses and is kind of used throughout any type of, I don't know what word that is. Just pretend that says terminology. All right. The first one is called the null hypothesis, all right, which we'll designate in shorthand with H with a little zero on there. So it's called H naught is how you can read that. Right. The null hypothesis, or H naught, this is the claim that's being tested. Okay. So what we said before, if you looked at the two examples we had on the previous slide, or a couple slides back, was that 80% of Americans like cheese. right? So what we'd say here is that H naught, that claim, is that mu, the average of all Americans that like cheese, is 80%, right? Now for this thing, we usually like to report these things as proportions, so let's say mu equals 0.80, right? The second one was that when we looked at light bulbs, right, we said the average light bulb has a life of 300 hours, right? So for that particular null hypothesis, we would say that mu equals 300, right? So mu equals 300 hours. Okay. So the null hypothesis is again the claim that we're going to be testing out. Right? The second thing we need to know is what's called the alternative hypothesis. Right? And we'll denote this with H with a little 1 underneath it. So it's pronounced H1. Okay? So what the alternative hypothesis H1 is, right? This is the statement that we are trying to find evidence to support. Whoops, I don't know what that word is. Evidence to support. All right. And just as a quick little note here, when we're doing our hypothesis testing, right, the testing that we're doing, it does not prove the null hypothesis, right? So it does not prove H1, right? All we're doing with our testing is that the only thing we can do is disprove the null hypothesis, right? So in all our conclusions that we'll see at the end, our answers will be we either accept the null hypothesis or we reject the null hypothesis, right? We're not saying the alternative hypothesis is true. We have to do a whole different test for that. Really, for the hypothesis testing, we're trying to decide if something is not true or not. Okay? So here are what some of these examples could look like. Right? So let's say I have this null hypothesis H naught, and we're testing the cheese conundrum. Right? So we would say that mu is equal to 0.80. For our null hypothesis, we've got a couple of things that we can look at. All right, one is we think that the mean American or the number of Americans that like cheese really is smaller than the 80%. Right? So in which case, the null hypothesis would be the mean should be less than 0.80. Right? Another case, if we're testing this null hypothesis, would be that we think Americans love cheese, in which case the percentage should be higher. Right? So we would say the mu would be greater than 0.80. And yeah, my bad, I made a little boo-boo there. It's not H naught. Right? It should be the null hypothesis H1. Right? And here's the third type of test we can run. Right? So here's the claim. The last alternative hypothesis would be this, is that I don't care if it's too big, I don't care if it's too small, I just think it's different. I don't think it's 0.80, right? And the other two we had directions, either too big or too small. In this case, we're just saying it's just wrong, it's just different, right? So I would say that mu, it's just not equal to 0.80, okay? All right, so when we look at these three types of tests here, they've got three different names to them, right? These types of tests for the first two that we've got here, right, these are called one-tailed tests. Right, because we only care about one side, either the smaller side or the larger side, right? If we think it's smaller than the claim, we would call this a left-tailed one-sided test. If we think the mean should be bigger than, we would call that a right-tailed one-sided test, right? And for this third case, well, we think it's either bigger or smaller. We don't care, so we're covering both sides. So this would be called a two-tailed hypothesis test. Okay? So when we come up with the procedures, which we'll start looking into in the next section, there are really four things that can happen. Right? So let's make a little chart here to see what could actually happen here. Okay? All right. So first thing that can happen is maybe the null hypothesis is true. All right? Of course, the other thing that could happen is that the null hypothesis is wrong, in which case we might favor this alternative hypothesis. So let's say the alternative hypothesis is true. Okay. So when we're doing our test, there are two things we said that can happen. We could either accept the null hypothesis or reject it. And accepting could be kind of strong, because what happens if you said alpha is 5% and you got it happens 5.1% of the time, to where there's still some ambiguity that's in there. So what we don't want to do is this, right? We don't want to say that we accept the null hypothesis, right? What we're going to say is that we do not reject the null hypothesis, right? In other words, I didn't find any evidence to say that you are wrong, right? So again, I'm not necessarily supporting them. I'm just saying, based on this evidence, I can't prove that you are incorrect. Okay? So we can either say that we do not reject H naught, or maybe we look at the data and we say there's no way your claim is right, in which case we reject H naught. Okay? So those are the four things that can happen, right? Either the alternative hypothesis is true, it's false, and then we could either reject it or we could not reject it, right? So those are four things that can happen. So if we think about what works and what doesn't work, if H naught is actually true, let's say their claim is true, then we don't want to reject it, right? So in which case, this would be the correct conclusion from our work. Right? In other words, their statement was true, we tested it, we didn't come up with any evidence to say anything to the contrary, so we got the right answer, right? The other thing that can happen that's right is we look at the evidence and we find that the null hypothesis is wrong and we reject it, right? In which case, this is when we get a correct conclusion here, right? In other words, their claim is wrong and we found evidence to support that it's wrong, right? So those are the two ways these things could go right, right? Their statement is correct and we didn't find any evidence to the contrary, or their statement is wrong and we found evidence that it's wrong, right? So that's how things can go right for us, right? Here's how things can go wrong, though. Let's assume that their statement is actually true and we happen to pull out a bad sample, right? And that bad sample leads us to a bad result, which would cause us to reject the null hypothesis, right? So that's what this box is for right here, to where their claim is true, but I'm actually rejecting their claim. So in other words, I'm wrong, right? Their claim is right, I pull out a bad sample, and based on that bad sample, I said, I don't believe you, but I was wrong, okay? So when that happens, this is called a type 1 error. Right? That's when, again, their statement is true, but based on the sample, I couldn't believe it's true, so I said it was false, right? So I could not accept their null hypothesis. Right? The other way that this can go wrong is that their statement is wrong, and I pull out a bad sample that still corroborates what they're saying, right? So that's this box right here, right? That type of issue is called a type 2 error. Okay? All right, so based on pictures, here's what's happening. All right, so we are going to be using this idea of the normal distribution. So in other words, we're going to pull up pretty big samples so we can use this. Here's their claim. Right? So here's the null hypothesis, right? That mu equals some number. Let's call it C. Right? But what happens if we think it should be for the, how about the right-sided test where it's too big, right? We think the mean really should be over here someplace, right? So here is H1, that mu is actually bigger than C. Okay. All right, so here's what can happen. Let's say their claim is true. Then what I'm going to do is I'm going to find this area, right in here, right? Or this area right in here, depending on which side you want to do, right? If this is, 4% or so, then I wouldn't reject it, right? If we said 5% is my level, right? So in that case, if their claim is true, and I pull out evidence which says, okay, this says that the sample should only happen 4% of the time. Okay? So if their claim is true and this only happens 4% of the time, right, this is evidence against the null hypothesis. Right? Because basically what this is saying is that our sample should not have happened if your claim is true. but our sample did happen. Therefore, your claim is false. Right? So whenever our data gives us a really small probability that the sample occurs, that's evidence against it. Okay? So what can happen is I could get a big p-value. Let's say, what if my area over here was 7%? Then I would support their claim. Right? Or if it's a small number, I would reject their claim. Okay? By the way, that level of significance that we talked about before, alpha, that number actually represents a type 1 error. Right? So if I set alpha to be 5%, and I got 4% as my answer when we did our statistical analysis here, right? Then that's what would give me the boo-boo here. Right? In other words, if their claim is true, but I rejected it, then that's a bad thing, right? So when we talk about level of significance, we're really talking about the probability of a type 1 error. Okay. All right, so what we're going to be doing, at least in these particular sections, is we're going to, maybe not us, but someone's going to make a claim. We will then collect data. We will analyze data. Right? And then the last thing we need to do here, the last step that we will make, is we will state our conclusion. Right? And that's that either we do not reject H naught, or we reject H naught, the null hypothesis, in favor of the alternative hypothesis. Okay. Now again, I'm not saying the alternative hypothesis is true at all. I'm not saying that. We would have to do a test to see if it is true, but we're saying we either do not reject the null hypothesis or we do reject the null hypothesis. All right, so this is just an intro, so not a whole lot of statistical analysis being done just yet, just really setting this stuff up and thinking about it. So I've got a lot of problems for you to go through, but a lot of them will just be really quick, easy things. I bet over half these things you can get done in about 5 minutes, right? So look at these problems in section 10.1. Look at 1 through 14, 15, 16, and 17, right? Followed by 20 and 21. And then 23, 24, and 25 kind of go back to 16 and 17, so maybe you want to do those together. Right? And look at 35, 36, 42, and 43. I know it looks like a lot, but a lot of these are just short, fill-in-the-blank type of things, so I would be really surprised if this takes you more than 30, 45 minutes or so. Always, if you need some help, contact me. We can set up a time to meet on email, on Google Meets. Let me help you out. All right, so if you get frustrated with this stuff, do not hesitate to call me. Let me do what I can do to help make this as easy as possible for you. All right, miss you guys. Hope things are going well. I will talk to you soon.